Angular velocity is the rate of change of an object's angular displacement divided by the time that it takes to travel whatever that displacement may be. So for example, if I had a circle and we have an object that starts, let's say, at the very top and then it goes over to this position over here. Let's say this is the center of the circle. The displacement that we're looking at here is going to be the angle theta that it travels. And let's say that it travels from there to there in time t. The angular velocity is defined as omega, so lowercase omega, and that is equal to the change in the angle divided by the time that it takes. Technically, it's going to be the time interval, so delta t. So what this means is that whatever you're looking at here in terms of your object, it's not dependent on the radius, it's not dependent on any linear position or linear displacement, it's only dependent on the change in the angle. The typical application that we will have when we're looking at the angular velocity of an object is if we had an object moving an entire circle, so going from the very top back to the very top, its displacement is going to be 2 pi because the angular displacement is measured in radians. So if the object's displacement is 2 pi, the time period that we would be looking at for our displacement in the entire circle is the period of the circle. So we use capital T for the period. This is a very common way to represent the angular velocity. In terms of the units of your angular velocity, the SI units are just going to be radians per second because we're just looking at the amount of radians that the object has traveled in the time in seconds that the object traveled. And so that's how you just get your radians per second. A very common unit that you will see though is going to be RPM. So RPM is revolutions per minute. When you look at a lot of rotational objects, you will be given the angular velocity in RPM. So for example, if you're looking at the rotation of your tires, you're going to be given the rotation in RPM. What you'll need to do is you'll need to convert your RPM into radians per second. Easiest way to do that is that we know that if we have, let's say, X number of revolutions per minute, we're just going to use our factor labels. So if I just multiply, I know that 1 minute is equal to 60 seconds. And I know that there's 2 pi radians in 1 revolution. So essentially what you're going to do is if you have X RPM, if you multiply that times 2 pi divided by 60, that will convert to your standard radians per second. So you need to be very careful just to make sure that you're using the appropriate units when you're calculating the angular velocity of an object.